In this video, we're going to look at how we form salts from metal oxides and also metal hydroxides, very similar reaction. So if we look at the example here, we've got copper oxide, which is a black solid. All metal oxides are insoluble ionic solids, except for actually the group 1 oxides, which are soluble. But group 1 compounds are always soluble. So everything else will be insoluble. I'm going to react that with sulfuric acid, and we're going to form a blue solution of copper sulfate, and some water's formed also. Okay, so we need to say what is a salt. Well, most people's definition of a salt would be it's the compound formed when the H+ ions in an acid are replaced by metal ions. Okay, so if we have hydrochloric acid here, the salts that you're going to get are going to be called chlorides. So we could have an example of that. We could have copper chloride and sodium chloride. They're both salts. If you use sulfuric acid, you're going to get sulfates. So the example of the salts there would be copper sulfate, that in blue, and sodium sulfate if you replaced it with sodium ions. Finally, if you use nitric acid, that's the only of the acid we need to worry about, you'd get salts called nitrates. So you can get there, you get copper nitrate, which has that formula, or sodium nitrate, which is like that. Let's just talk about those formulae very quickly before we move on. Just to remind you that copper is a 2+ ion, and the chloride is 1-, so that's why you're going to get copper CuCl2, whereas sodium is only a 1+ ion. So the form of sodium chloride is just NaCl. Then we need to remember the sulfate ion has 2- charge on it. So sodium sulfate is Na2SO4, whereas copper sulfate, because that's a 2+ ion, you just need 1 copper 2+ for that, yeah. The nitrate ion is 1-, so it's going to be similar to the chloride. So you need just 1 nitrate for the sodium, because the sodium is 1+, but you need 2 nitrates for the copper, because the copper is a 2+ ion. Okay, so hopefully you're okay with how to predict those formulae. Right, so let's say I've just used copper and sodium there as examples, but you could use any metal, magnesium, so you get magnesium sulfate, magnesium nitrate, or if you use zinc oxide instead of copper oxide, you're going to get zinc chloride or zinc nitrate, zinc sulfate. Okay, it's the same every time. Right, let's just have a bit of a closer look what's going on with that copper oxide reaction as an example. Okay, so here we have got sulfuric acid. This is sulfuric acid, the covalent molecule before you dissolve it in water. But of course, as soon as you dissolve it into water, you're going to get 2 hydrogen ions, which I've drawn there as red, and you get 1 sulfate ion, SO4, 2-, which I've drawn as a purple. Right. This here is supposed to be the copper oxide ionic solid. So what you've got, that's a bit of copper oxide lattice there. So you have got the blue things are oxide ions in the copper oxide, and the silver are the copper 2+ ions. So that's actually a black solid. So you put that in the acid, sulfuric acid. It will react at room temperature, but if you do it in the lab, you usually warm it up because it makes it react quicker. Now what happens there is each of those oxide ions grabs hold of 2 hydrogen ions and forms water. The oxide ion is 2-, and each hydrogen is a plus, so that makes a neutral water molecule. So you're going to form there's actually 5 oxides. I'll just do 4. So you're going to form 4 water molecules, which I'll draw here. Put the hydrogens on them. So that's used up all the hydrogen ions from the acid. There's the water, and just to remind ourselves, so it was copper oxide plus H2SO4 goes to form copper sulfate and H2O. So we don't know H2Os. Now the copper sulfate, you can see, well, when those copper ions have been freed from the lattice, okay, because the oxide ions have all formed with water, so you now have these copper 2+ ions floating around. I'll just do 4 of them. And what you also have left in solution, they haven't actually reacted, they're kind of like spectator ions, aren't they? The sulfate ions, and you've got 4 of those from the acid. Now at that point, they're not joined onto the copper, but if you evaporate all the water, what you're going to end up is you will end up with an ionic lattice of copper sulfate. Okay, so that's what's happening in the reaction there. Right, very similar situation with, let's see what happens when copper reacts with hydrochloric acid in this diagram. Okay, so hydrochloric acid, we take the monobasic acid because it's only got 1 hydrogen there, whereas sulfuric acid had 2. Now that's a covalent molecule of hydrogen chloride. When it's dissolved in water, it splits up, dissociates into the hydrogen ion and the chloride ion, which is drawn as green. And there again, we've got our lattice of copper oxide, copper ions, the 2+, and the oxide ions, 2-. Okay, so what happens is each oxide ion will react with 2 of the H+ ions to form water. So form that. So we've got all the other water molecules. We've got 4 of them. React with all of those oxide ions, so we form the water there. And what we've left in solution are, this frees up from the lattice the copper ions, so I'll draw 4 of those. So these are the copper ions in solution. And what's left over from the acid, which these haven't changed at all, have they, like the sulfate ions, are the chloride ions, and I've got 8 of those. Okay, so what I'm left essentially with is a solution of copper chloride there. So we've got copper ions and chloride ions in solution. So the formula of copper chloride is CuCl2 because you need 2 chloride ions for every 1 copper, because the chloride's only 1 minus the copper's 2+. So that's the formula of that. And of course you haven't got the solid there, but if you evaporate all the water, then you'll end up with an ionic lattice of copper chloride forming there. Okay, so that's what's happening with the oxide. Now, if we react it with the hydroxide, it's a very similar situation. So if I just use, let's do copper hydroxide. So copper hydroxide has got that formula. And that's because, of course, the hydroxide ion has got a 1- charge. And if you think, what does each hydroxide need to turn it into a water? It needs 1 H+, doesn't it? One of our H+ from the acid. And we're going to form water again. That's the H+ from the acid. So that's going to react with, let's say, should we say sulfuric acid, H2SO4, aqueous. Should put the solid there for that. You'll form an aqueous solution of copper sulfate. And you can see you're going to form water, and you're actually going to form 2 water molecules there to balance the equation. I could do another one. Let's just do aluminium hydroxide, because that's a different one. So let's have that aluminium hydroxide. That's OH3, and let's react that with that's a solid. Let's react that with nitric acid this time, HNO3, aqueous solution. Okay, so we're going to form water, and the salt we're going to form is aluminium nitrate, and that has that formula because if you remember, the nitrate has got a single negative charge on it, whereas aluminium has got a 3+ charge on the ion, so it's AlNO3 3 times. Okay, what do we need to do to balance that? Well, we have got 3 nitrate ions on the right, so I need to put a 2 there, sorry, a 3 there. And then we've got 3 H pluses from the nitric acid are going to react with those 3 OH minuses to form 3 molecules of water. Okay, so metal hydroxide or metal oxide doesn't really make any difference really. With acid, with an acid, it gives you a salt and water.